2. We're basically just continuing here, but if you put a 50-minute video, sometimes you lose people. All right, I've done one thing since I stopped, and I just added a new row to the top here, 0.975, and that's just going to be to compare this to figure 9.2 a little bit better. So, and then I added that to my plot. You can do that by, if you click on the plot, you can adjust the data range that goes on the plot. So I've done that both of these. Right, so we've included that extra point. And now I kind of want to jump ahead to question D. So how do these results change with a different acid and a different Ka? There's another thing I want to do. I'm going to hold down Command, and I'm going to combine these into one plot. And so it should work out for you. Highlight it like that. I'm going to do a scatter plot with lines. And there we go. Double click on the axes. And let's go 2 to 6. And then, we could adjust the names of things and such, but there it is. So there they are combined into one, and that should look a lot like figure 9.2. Only there's something, it's been shifted, right? So the question, what happens, or how do the results change with a different acid with a different Ka? Right, because in 9.2, they had a pKa of 5, and we have a pKa of 4. And so how does it change, right? What's different? Literally, it just shifted along the x-axis, right? So this is centered at 4, or minimized, the buffer capacity is maximized at 4. If I wanted to change it, here's the power of Excel again, right? All I gotta do, change pKa to a 5, and the whole sheet updates. And if you, let's look, I want you to look at this column here when I do that. Okay, and this column, so the delta pH column, does delta pH column change? No, it does not change. So all that changes are the pH, the new pH change by 1, right? Because pH is pKa plus log, right? And so the log stuff, all that's identical. And the pKa just goes up by 1. And so now this turned into figure 9.2 exactly. So to answer this question D, if you have a different pKa, it's just shifting the plot left and right. That's it. That is it. Now the steepness could change, right? If we add more acid. Oops. That's that messed up, but that's because that's not a number. There we go. So now, if you add more, right, it gets real steep up there at the edges. But look down here at 5. The pH change is still, maybe we can look here, where it's 50-50, 0.03. So we doubled the amount. And it's 0.017. So it still went up, but it's still really small, right? So I think, let's see. But over here at the edge, it starts to get really bad. So the pH is changing a lot. So this is again showing how the buffer is pretty resistant to change, even if you're adding quite a bit of base. Man, what am I doing? Oh, I think I got past. I added too much there. So, but we see it adjust, and so it's kind of fun to play around with different things here and see how the plots change. Okay, so let's look at part C, and I'm going to rename this and then I'm going to make a new sheet. Sorry about that. And in doing so, I'm going to copy this part into a new sheet. All right, so there's exactly what we did before. We're adding a base. I'm going to give it a new title now. Total moles is 1. And we're going to copy this again, but we're going to change the total moles to 2. And we're going to see what happens. So copy and paste. And now what effect does that actually have on our cells? Remember this number was 1 minus, and now we want 2 minus. So I'm actually going to change these values because they're supposed to add up to 2 now. And so let's just spread them out like 1.94. This is going to be 2 minus so like 1.9, 1.8, 1.7. And I wanted to show you also, if you have an even interval that you want to continue, you can highlight like 3 of them, and you can see it'll continue for you. So let's take this all the way down to here. Keep it symmetric. So there we go. That's it. It's done. Isn't that awesome? All we had to do was just copy and change a few things. So PowerPoint's great. And now, the ratios are, well, it doesn't matter. We have the pH, but the ratios are pretty similar to what we had over here. And all the formulas just followed right through. And now we want to plot. Maybe we should put these on the same plot together. So we'll do them all, and we'll see how things changed when the total moles of the formal concentration increased. There we go. So the blue one is the same that we had on the last sheet, and the orange one is our new data. Something happened here at that point. Something seems weird. Let's see. pH of 4. I don't know what happened there. It looks kind of weird right there. Like there's a point missing. It should be a little bit, it should be smoother than that. But we just carried everything right through, so it seems all right. I don't know what happened. But the point is, right, look at what happened. So if you have a higher formal concentration, it's even more resistant to changes in the pH. So the overall curve is similar, but now it's just pushed down, right? I don't know why it looks weird, but maybe we'll try changing these numbers a little bit. Just to a different range. Nope, it didn't really fix anything, did it? It looks different than what I have on my other screen, and I'm not sure what's up with that. Oh, okay, I know why. I made a mistake. They don't have the same initial pHs. They're slightly different, right? So let's break this up. Let's try again. Right, this column and this column are not identical. They're similar, but they're not quite the same. Because I didn't just double everything. We could. Oh, okay. I have an idea. Let's just do it. I'm gonna undo. I'm gonna put that back. Okay. Let's try saying this is equal to this one times 2. So all we're doing is just doubling. And that cleaned it up. Because now they should have the same initial pHs. So this column N, column E are identical now. Yeah, that looks much better. I'm glad I figured that out. See, sometimes things happen and you don't know why, and it's good to take a few minutes and figure it out. So there we go. Same result essentially, but it looks much nicer. Okay, and then part E is I would leave that for you. You know what? I'm gonna put part E as the post lecture questions for you to answer, and I also would like. Hopefully you've been following along. I didn't say that, but hopefully that was clear at the beginning. I want you to send me your file, and then I'll put part E as your post lecture question. So now I have 2 sheets in this file, and I think that's enough. I think that's good for now. So you can see how the buffer capacity changes based on the initial pH, and also pKa. If you change that, the whole thing just shifts. And if you change the total number of moles, the greater the formal concentration, the more resistant to change. And we did it for both adding acid and adding base, and you see the inversion symmetry there. So, okay, that's it. That's actually it for chapter 9, honestly. There's another section about indicators that you should take a look at, but I'm not going to lecture or video about that. So I will get a chapter problem set up here for chapter 9. All right. Bye-bye.